Hi everyone, this is Podlodka podcast. You're probably surprised that all of a sudden Podlodka started speaking English. Well, actually, that's not our first time. We already had awesome episodes in English with Chris Richardson about microservices and with Björn Straustrup about C++. As our frequent listener, you should know that we really love making episodes about programming languages. And today, you'll learn about Darklang, which is very special. It's a product that combines a programming language and infrastructure for backend services, ecosystem and tooling with the final goal to remove the accidental complexity from software engineering. Before we start and before I introduce our guest, I wanted to share why I voted for this topic. It's a small personal story. Last week, I was working on a very simple web service. It just takes some data from a post request as an input and use it to create an image. I need the service to work literally just a couple of times per week. It's not something complex, it's a very easy thing. I spent about maybe an hour implementing the image generation logic, testing it, and about 3 days fighting with API gateways, lambdas, ST integration, access management, the whole AWS, because it was literally, I didn't understand how to deploy it. Such a simple task and so much time spent on unnecessary details that are not core of my business. And when I first read about Dark, I think in 2019, probably, I was really fascinated of how it reduces the unnecessary complexity. So, when we were looking for the first topic, I remembered this, how I struggled with AWS, and I talked about it to my co-hosts, and, well, here we are.
Yeah, I can catch it up from here, and I think my story is pretty much similar, but a little bit different. Back in, I think, 2014, when I was developing using .NET, I was thinking about switching to Java, and I thought that it's going to be easy because, well, Java is really very much looks like C# or vice versa. And when I started diving deeper into the Java ecosystem, it turned out that language is just a small part of this whole ecosystem because I needed to understand how Maven works, how Gradle works, how all this Spring ecosystem works, and it was much more complex than Java. So when I learned a little bit more about Darklang, it was so interesting, so thrilling to understand how this whole concept works when the language is also the ecosystem and the tooling and all of this is wrapped around one solution. So I'm really excited today to talk about Dark language with our guest.
Before we start, just a minute of your attention. If you're a PHP developer, be sure to visit our online conference Podlodka PHP Crew. This time we focus on advanced tooling with lots of workshops and live coding featuring PHP Storm, Composer, various static analyzers, and many more. The conference starts on February 27. Use promo DARKPHP to get a discount. Promo and the website link are in the episode description. See you on the conference. Okay, fine. And now, let me finally introduce our guest. Today, with us is Paul Biggar, CEO, CTO of Darklang, formerly founder and CEO of CircleCI, and PhD in compilers. Welcome, Paul.
Thank you. Happy to be here.
Before we start, can you please tell us a short story about yourself, how you ended up being CEO of Darklang, how you ended up trying to kill all the modern backend development stack and replacing it with something better?
Yeah, so let me see. After I did CircleCI, I took a sort of a long sabbatical and I tried to figure out, what to do with my life. It was about 18 months. And at the end of it, I started thinking, I want to build a small company. Like, I want to build something that's, a simple app, maybe a SaaS that I can build with maximum 5 people that I don't have to raise VC for. A nice small company that makes a nice small thing. And as I started thinking about how am I going to do that? How do I avoid just becoming someone who sits on the pager for years for my services. How do I keep, this application that I'm going to build? How will I keep it up? And I started realizing just how much overhead there was in building things on the cloud, or even if I was to do non-cloud, there's still a lot of overhead of this. And basically every idea I came up with, I was like, oh, that sounds like a nightmare to do the infrastructure and that sort of thing. And so there was this other idea that I'd been thinking about for years that I had dismissed because it seemed like too much work. It's going to require raising a lot of money. It's going to, require a large team. And the idea was basically Dark. This sort of replacement of everything that allows us to make these apps simpler. And so as I thought about all these apps I wanted to make that were, that should have been simple and weren't, I kept thinking, well, if I had this other thing, then that would be possible. And so in the end, I went and I'm making the other thing now.
Most people usually have some intuition about what a programming language is. Usually, when we say programming language, we mean a compiler, some semantic rules that create language design, maybe some standard library that provides you with some basic building blocks, but usually that's all. In other words, a programming language is a set of tools that helps you to deal with your tasks, that translates programmers' ideas into some executable apps. But Dark can hardly be explained with this simple definition, because it's so much more. How do you usually explain to people who don't know anything about the project what is Dark?
The fundamental idea of Dark is that we want to remove a lot of what you described earlier as unnecessary complexity. So you're talking about this API gateway and Lambda and that sort of thing. And the reason that programming is complicated these days is because we're taking a lot of things and we're bundling them together. So we're building these programming languages as compilers or as interpreters that run on Unix machines, and they run on a command line, and you take text files and you convert the text files into maybe executables. You put those executables on a Docker container. You put the Docker container into a Lambda. You script the Lambda with, whatever it is, step functions or whatever. The reason that all these things exist is because they wrap existing languages, and existing languages run on computers, right? That's sort of their intention. We built these things 20 years ago, mostly, and we built them to run on, let's just say, Linux machines, right? And so the interface to them is a file system and POSIX and that sort of thing. And we're doing so much more with them, and things that we want to do that's more with them, we attach to them, we slap on the front. And as a result, there's, at every connection between the different systems in our ecosystem, there's friction. So we want to do source control, so we use Git. And right, what do we do with Git? Well, we're using text files because Git has to work for every language. And as a result, we are still, using the file system as an interface, and we have all sorts of difficulties like, what happens if we have the permissions wrong on different systems, or, there's a multi-case thing going, or, capitals versus lowercase on different Mac versus, it's just sort of these weird little impedance mismatches, and they all add up, right? SQL is another example, right? We have ORMs where the types aren't exactly the same at either end. If you don't want to use an ORM, you have to write SQL, and the type in the database isn't exactly the type in the language, isn't exactly the type in JSON, all this sort of thing. So my theory was that we have to integrate all these things. The only way to remove the seam between them is for them to be actually the same thing. So in Dark, for example, there's no HTTP server that's running on port 80 that you put in a container that you connect to a load balancer, right? You just create a HTTP handler, and that's live in production. There's nothing else to be done. Similar, if you want to save something in the database, you can take one of the Dark values and put it directly in the database. You don't need to think about, how am I going to serialize this? What is the right way to query this or to put it into data store? What is the right type? It's just, the types exist in the data store as they do in the runtime. So it was just, realizing that we can remove all of this complexity. The only way, in fact, to remove the complexity is to make them integrated into one piece. And we picked as sort of the boundary of everything, a HTTP. So it's HTTP request reaches us and responds to us, and everything within that is ours. So there's no GitHub, there's no Git, there's no file system, there's no operating system, there's no Lambda, there's no API gateway, there's no HTTP servers, there's no SQL. There's just a simple, straightforward language and data stores and queues and events and cloud and HTTP is all wrapped within that with like very thin layers.
I think that's a beautiful idea because it's really very simple and easy to understand. But I think we probably can agree that whenever we try to integrate many moving parts, it really makes a lot of things more simple, but also it kind of reduces the flexibility. So the number of use cases when we actually can use the tool is becoming a little bit more narrow. So could you probably highlight some like most specific use cases when the Dark language is the best choice, or maybe there are some use cases when it's absolutely no-go, when it's not suitable at all?
Yeah, I think you're totally right. When I was deciding to do Dark, part of the question was, is this actually useful for enough things? We are definitely saying that it can't be used for something. So like very obvious example, you can't build embedded systems with Dark, right? This is a cloud-only thing. It doesn't run on your machine. And this isn't something that you would build embedded systems. It's not something you'd build front end. It's not something that you could build standalone desktop apps with. Like, we are deciding that it is not suitable for that because we want to make it suitable for what I think is a pretty big niche, which is the back end web cloud sort of thing. And then the question became, if it's going to be fully integrated, right, what aren't we going to be able to do in it? And a very simple example is like we decided that we're not going to do like heavy computation in it, right? We're not going to expose things like image editing, right? Those aren't going to be the kind of functions that you build with Dark. And maybe they will be later, maybe when Dark is like fast enough and has enough libraries that you can compile down something that is as performant as ImageMagick, but that's not where we are now. What made me realize that it was going to be possible to do Dark is the fact that everything is sort of done via HTTP interfaces these days. So a lot of people, if you're building a monolith, maybe you include ImageMagick. But after you get to a certain size, you probably use an imaging service. Maybe you're using a vendor, or maybe it's just sort of a microservice that the imaging team is working on, if you're Twitter size or something like that. So we realized that like anything that doesn't fit in Dark is going to be something that you can just put in another service and speak to by HTTP. So what Dark is good for then is anything where it's appropriate for the scale that we can handle because we're a small team, but also where it's just sort of, you have a HTTP server and you want to receive data, process data, store data in a data store, maybe run some events in a queue, maybe some WebSockets, that sort of thing. Like, 90% of most backends, 90% of most web apps, 90% of most, most services, most B2B things can all be done in Dark. And anything that can't be run in Dark, you can just talk to via HTTP. That's sort of our foreign function interface. So if you want to use, someone asked us the other day, like for something that was roughly Elasticsearch, it was like, well, there's vendors. There's a large handful of vendors that provide this sort of functionality, and we can just speak to them via HTTP. So if you want to use you want to do something with that, you can use Algolia, you can use your a cloud provider's Elasticsearch version. You could even spin up Elasticsearch, put in a container, put a HTTP front end on it if you really wanted to. So when it comes to like flexibility, that's sort of the escape hatch.
Looks like it's not only the tool and the language to create services, but also the way to build the whole system, also including other services made in different languages, just by exposing HTTP API.
Right, exactly. So we won't run your containers, but you can do anything and talk to it via HTTP, and that's kind of the simple thing. But in addition to like the runtime, it's also the editing environment. So for example, I mentioned that there's no Git. What there is there's instant deployment framework and built-in observability debugging framework that you can only get when you combine all these things together. The idea is not just there will be less work to do, or less sort of like code to build or less frameworks to learn. It's also like this is a better way, and this is maybe how coding should be in a certain sense.
And why did you decide to focus on the backend development? Because backend services, they rarely exist all alone. Usually there is an app that has a front end or mobile app. It interacts with the backend, and even if you manage to provide an integrated solution to create a backend that removes removes all the complexity, you will still have to handle with all this front-end hell, with those variety of frameworks, NPM, and all of this stuff. So why backend? Why not front-end? And why not everything all together?
Yeah, I think the main reason was that I didn't really have a good solution for front end. I sort of had this idea that I've been working on in my head for a few years that I thought could actually be like a really good solution for the back end. I just like, I knew front end. I had written plenty of JavaScript and front end apps and client apps and that sort of thing. But if you look at sort of the space of clients, okay, there's front end, but there's also native apps. There's iOS and Android, and there's other places you can put clients like TVs, command line, that sort of thing. I just didn't have kind of any solution for this, any kind of thing that like looked really good, and I thought I had a pretty compelling vision for the back end. So that was where we sort of drew the lines. You have to draw the lines somewhere. If we said, okay, we're going to do back end, but we're also going to include this like front end library. And then it's like, well, everyone's building React and everyone's building Next.js, or they're building Vue or whatever, or they're building iOS apps, right? And we're telling all these people, well, you can't really, you can't use Dark for this because you have to use it with our built-in framework. It didn't really feel that compelling. And maybe later we will add, an optional framework. Maybe people will build React-like frameworks that sort of, work nicely with Dark, or maybe that, build a Vue plugin for Dark. I think that would be sort of the compelling way to make better front ends for people who use back ends, but we definitely don't want it to be compulsory or for people to think of it as, oh, I can't use this with, Dark or Swift or whatever, or with React or Swift or whatever.
Mm-hmm. Which languages or frameworks do you consider as competitors or alternatives?
That is a good question. So there aren't any direct competitors, which is kind of always a bit of a bad sign when you're building a startup that you're the only one doing it. So, But it's sort of thing where anyone who's building a backend, if there are other compelling visions for how to do backends, they are obviously competitive. If you build your service on Lambda, you're obviously not building it on Dark. So the ones that are sort of closest to it are things like Glitch or Replit, where you have this sort of like live editing, or things like Render, where there's like the full sort of packaging brought together. Things like any of the serverless frameworks, serverless.com, I think is a thing that's trying to pull more into their stack. But I think there isn't really anything where even new startups tend to do like one or two of the four things that we do. And, I haven't seen anything else that's really trying to do, both we simplify cloud and we simplify development and we sort of pull it all into one.
For me, it looks like kind of maybe Python, because it's also the language that so-called as the best second language in any area, even on mobile platforms also.
Yeah, that's an interesting idea. One of the reasons that we didn't reuse an existing language like Python, which I think is a lovely language, by the way, is that I felt that they weren't like quite good enough. And in particular, when I looked at what I felt made it easy to build applications and for people to be able to reason about their programs, I felt that functional programming languages were sort of like an essential part here, and especially immutability and static types and enums or some types, variants, depending on the language is what they call them. I felt that these were like the real kind of like phenomenal tools that allowed programming to be simpler. And so if we're going to build this sort of like simple, maybe I don't want to pretend that it's like dumbed down, it's still a Turing complete programming language. But if I wanted to build something where it was easy and straightforward and easy to understand programs and that sort of thing, I felt we didn't want to pull in the complexity of either existing languages with often decades of object-oriented or dynamic language sort of stuff in them, which I feel were sort of missteps for the industry, or to pull in things that had existing ecosystems. So, if you're going to use Python or NPM, there's a whole ecosystem, right, that requires things like these run properly on Unix machines. There are file systems, there are files, these are kind of fundamental concepts, and they weren't fundamental concepts in our view of the world. So it didn't really make sense.
Okay. So your vision is to remove accidental complexity from the backend development by providing some integrated solution. But can you share us some key principles that implement this vision? So one of them you've already mentioned, it's choosing a functional language because it's so much better. But what else?
Let me take a step back and sort of focus on what it was we were trying to do. We highlighted at the start several areas of complexity where this complexity came from. And so we decided we are going to remove these things. And so the sort of the main 4 areas of it are the cloud complexity, the deployment complexity, the API complexity, so using APIs, and then the coding complexity, things around like a dev environment and, setting up tooling and even static analysis and that sort of thing. So our philosophy started from how can we make these things as simple as possible? So with deployment, the very obvious thing is if you want to have the fastest possible deployment, the fastest possible deployment is 0 seconds. And so we are going to have to build something where deployment is a 0. Every keystroke goes into production immediately. And so if every keystroke goes into production, then there has to be a safe way to bring every keystroke in production. So we built our language around this. So there's no syntax, there's no parser in our language. Every keystroke goes straight into production, but safely. So there are ways of doing intermediate state in our language where when you make an edit, it's still safely running until you have completed the work that you are doing. And that stuff is built into the language, it's built into the editor, it's built into the framework. We have designed it to be safe. If you've ever, coded PHP on a shared server in the old days, you realize that it's fundamentally not safe to just edit the files directly. But with Dark, it is safe. And it's built into the language. There's also feature flags, again, built into the language. So this idea of, 0 second deployment was one of the key principles. And then one of the other key principles is we're trying not to do anything particularly fancy. We're just sort of trying to remove all this stuff. And what is the simplest way to remove all this stuff? But we do get some really cool stuff by the fact that we integrate everything together. So the fact that we are, your language, we are your code hosting, we are your cloud hosting, we're able to do some really fancy things. And one of those is called trace-driven development. So trace-driven development is the idea that you are building your client and your cloud backend together. So you build a form in your React app, you press the play button or the submit button or whatever it is, and then a request goes to the Dark backend. And if you haven't built anything at all, we are still going to record the request that comes in and provide that request to you as you write the code without having to rerun it. And what we get from that is that every piece of code you type, you can see the value for the request that you just made. Later, when your program is in use, the same thing works for debugging. So you can see actual requests that customers made. You can see, on line 17 of this function, that request gets turned into the value 5, where we expected the value 6. And then you can see the whole way through. And it's sort of like this always on debugger / this perfect sort of tracing, omnipotent, observability framework that's sort of built into it as well. And that comes from the fact that we have integrated everything together. So removing all the things and then integrating all the things is where that sort of simplicity and power has been coming from.
I've got a question about that feature where we can see the history of the precise variable, as in your example, about requests, how it can be implemented, because in case, some big services can process thousands and thousands of requests per second, and in case we try to log all these bunch of requests, how we can process them, save them, and after it try to debug something?
The answer to most of these questions is how would you do it today? We aren't at the moment dealing with customers who have thousands and thousands of requests in a good way. We will at the moment just store everything. Obviously, in the future, what we'll want to do is, provide the ability to throttle that, to automatically save errors, but not to automatically save every 200 result, every good result, and provide people with a sort of a view into them in the same way that you might with modern day observability tooling. as opposed to like storing absolutely everything. But yeah, in general, the answer to those questions is like, how would you do it today? So, you want to scale something, you're going to have to throttle it. You're going to have to, discard things, that sort of thing.
I think we already started to discuss several details of the whole project, and we already discussed the main concept. But still, if we will visit the website of the project, it says Darklang. So there is a word language in the name of the project. So I suggest we can talk a little bit more about the details of the language. And first question about that is, can you distinguish some features that can really make a difference with other programming languages? I mean, something maybe the most important things for you specifically.
So I've been programming in functional programming languages professionally since about 2011. I'd used them before that, but we built CircleCI in Clojure, and then we built Dark in first OCaml and Elm, and then secondly, we've moved to F# and Rescript, which are kind of similar. So this idea, the main thing is that immutability is like just the most powerful thing in programming languages. I think it's just a phenomenal feature. And when you contrast it to object-oriented systems and mutable things, you're often asking the question, where did this value change? Like, how did this value get here? And with immutable systems or immutable value, languages with immutable values, that question doesn't really come up. It doesn't ever just change over there. And it's also kind of a key feature that allows the trace-driven development to work, because we don't need to store like every value at every point. We only need to store the things that we know are impure, such as making a HTTP request to another service or something like that. And the rest is sort of implied. So I think immutability is just one of the best things. I think one of the other things to take from functional programming languages is enums. I think that they are just an incredibly powerful way of knowing that your code works. And they're much more powerful for encapsulation and composability than things like object orientation and, classes and objects and that sort of thing of various kinds. So I'm a huge fan of those. And we took those from, OCaml, Elm, F#, Rescript, Haskell, the main languages that are most similar to Dark, but they're also present in things like Swift and Rust. Those kind of the major new languages that are using them, or that are using similar topics at least. So those are kind of the major language features. Apart from those, it is a relatively simple language. The same thing that you expect from most languages. It's got strings, it's got, integers, it's got floating point numbers and booleans and whatever. It uses JSON. You can store things in a data store. But the real power, I think, comes from not just immutability, but how people develop when you write immutable programs. So it becomes a lot of like, it's not writing these huge class hierarchies. It's like, we've got a list of things and we're, iterating across the list. Now we've got a new list.
I have already asked you about competitors, but what about languages that have influenced Dark design?
I think the main influences have been, honestly, Clojure was one main influence. Like, even though we ended up not building something that was totally similar to Clojure, spending a couple of years of really understanding how immutability can make for a simpler programming environment, just like that was this major feature. And then as well, like understanding that even though we loved this feature of Clojure, that the lack of static types and that the presence of null was, was a real, whatever the opposite of a killer feature is, like a bad language feature. And I suppose that this bit came from Haskell originally, the use of variants and options and results and that sort of thing as ways of avoiding that and having like full static types. I would say that even though we ended up at a language that was most similar to Elm or OCaml, it was really from combining Haskell and Clojure, and then realizing, someone has already combined these languages, and they've, that wasn't the actual history of it. I think ML came first, but looking at Elm and OCaml, it's like, these are really good. This is some really good stuff, and it's not fully good stuff. We could, still some stuff to discard from those, but the really good influences there.
And speaking of other languages, we already discussed that one of the ways how we can integrate Dark with other ecosystems is through HTTP requests and all of that regular communications. But still, speaking of specifically language details, are there any ways to to have some kind of interoperability between Dark and other languages. For example, maybe plug in a specific C or C++ module, or you try to avoid these things?
We try to avoid these things. I think we may, try to plug some things in. So for example, we have some crypto libraries, if you want to do a SHA of a function, an MD5, that sort of thing. We have to really provide that for you. You wouldn't write that in Dark. It would be too slow and too difficult to implement anyway. But for the most part, we shy away from doing that. We want you to run it in another service or something like that. But there's no way to put some C in. Our implementation language is .NET, but even so, we don't want to just take the .NET ecosystem and put a nice bow on it, and now you can call these C# functions or something like that. That's not the plan.
Okay.
By the way, there was a really nice story about how you chose the backend for the language, the compilation target. Can you tell us a bit about your initial choice and why you decided to choose another language, how you chose the one to use?
Yeah, so there's a history there. I suppose the main idea is that the users don't get to see this, right? You just have code and it runs in production, and you don't really think about what machines is it running on? Even the architecture of the machines is invisible. We might switch to ARM someday and people won't know. So the initial version was actually Python, and that was something that lasted maybe a couple of months, and the language still didn't look anything like it looks today. So the first real version of Dark that people saw was built in OCaml. And I didn't know OCaml when we started. I'd used Elm a lot, and I sort of felt this was the back-end version of Elm. And it was a pretty good language, but it was one where there wasn't a significant ecosystem. In particular, we lacked a lot of cloud libraries, and we ended up making a lot of bad decisions because of the libraries that we lacked. And we sort of, at some point, decided, are we going to commit fully to OCaml, or are we going to decide to move to something else? Because we've been talking for years about, when we do the Rust rewrite, and everyone has a Rust rewrite in mind, and so I played with doing a Rust rewrite.
It is literally a discussion in any office today.
Yeah,
when we do a Rust rewrite.
Right. And we might still do a Rust rewrite, a couple of years down the line, but I felt it wasn't the right fit for where we were at the time. In particular, the async plus multi-threading is really difficult to do in Rust. You spend a lot of time working on, who owns this particular chunk of memory. And I don't think memory management is a useful way for people to spend time. And we got sufficient performance with another language, which was F#, which also came with a bunch of the stuff that we needed. The immutable, garbage collected, high performance async was a really good building block for the Dark language. It was a bit more high level, it's a little bit more difficult if we need to change the semantics, but actually the semantics maps, pretty directly. And that's kind of what happens when you have just this sort of, immutable language. It sits nicely on top of another immutable language. The other thing was that we felt that Rust didn't really have the high quality libraries for cloud integration that we needed. In particular, we were on GCP and it had high quality ones for AWS, but it didn't yet have high quality ones for Google at the time we were looking. So kind of combined with those two things, we decided that, we were going to spend a lot of time building this stuff in Rust. And looking forward, F# has been really great. .NET has been really great. The major changes that we're looking at going forward is writing more stuff in Dark itself and less stuff in other languages. But we may get it to the point where so much stuff is written in Dark that we can write a high performance, core. And we might look at Rust for that again. Or even we might look at, something like writing an interpreter in assembly or something like that for really high performance. But we haven't really looked that far, and that I think would be many years out.
I still have questions about the rewrite. So rewriting a compiler is a huge project, and as far as I read your blog, it was a bloody one. Can you share us some key challenges that you faced while rewriting the compiler from OCaml to F#?
Yeah, the old version was in OCaml, the new version was in F#. I was like, this is going to be quick. I budgeted 6 months and I was like, I might get this done in 2 months. Absolutely not. Not even close. It ended up taking 20 months. And I think there's a couple of reasons for that. One was, I think we could have done just, a rewrite from scratch in 6 months. But what we did instead is we wanted to make sure that this was a zero downtime switchover. Customers shouldn't see any difference and they shouldn't have to do anything. And that's part of the fundamental thing about pulling everything in together with Dark. We want to manage language migrations, language deprecations, library deprecations, all that sort of thing. We have the opportunity to build in. And so we didn't want this to be, a Python 2 to 3 kind of situation where people had to rewrite everything. And in fact, people had to rewrite nothing. We had maybe one user that had to make a minor change, but they weren't really using it. So they actually just turned it off instead. So that was kind of key. And so, okay, we need to make this work. That means that we need, the DevOps situation, spend a lot of time on DevOps to be able to switch, seamlessly from one to the other, making sure that we had full observability into our code. In some cases, we had to add observability into the old code to make sure that the code stayed working the same. As we did the rollout, I'm sort of going from the back to the front here, but as we did the rollout, we made sure that the results were the same, that the types were the same, the error codes were the same. And so going, closer to the front, we needed to make sure that everything behaved the same. So we needed much more testing than we had. We needed to build a full fuzzing framework to make sure that the old code and the new code worked the same. And we needed an interoperability framework, an FFI framework, all this stuff to make sure that the old values and new values were exactly the same, down to, in some cases, down to making sure that the white space in the JSON stayed the same. Because we had some JWT functions that used the output of the JSON. And if our users, some users use the JWT functions, we could have just discarded it. We could have said, okay, those users don't matter or something like that. But what was important to us, were something that was fundamental to Dark, was keeping it working as close to exactly the same as we could possibly do, really just not breaking any users. And that was important, not just from, that's sort of what Dark is, but also from getting the experience of learning what is a major migration like on Dark that damages no users. And in retrospect, I think we could probably have been a little more aggressive on it. Just from a business point of view, I don't think spending 20 months on something that might have taken 8 or 10, was the best sort of outcome. But we did learn just a huge amount about how to do this, and ended up in a place where, the monitoring and observability stack was really good. The auto scaling stack was really good. The testing and the fuzzing was there was basically no testing before. We had 250 tests. Now we have 11,000 tests. And a lot of those were just auto generated from fuzzing and from, things that hadn't got touched before, and errors that we found, all that sort of thing.
Let me change the topic a little bit, because we dug ourselves into the details of the language. But any talk about programming language will be incomplete without discussing the developer's environment. Specifically, I would like to talk about IDEs, because first point of interaction where a developer actually starts using the programming language is usually text editor or IDE. But for Darklang, you decided to choose another way. You decided to make some kind of visual editor. Why? What was the motivation behind this decision?
I don't actually think of it as a visual editor. It is only a visual editor in the sense that VS Code is a visual editor. You still edit your programs in text, and you're writing text and reading text and that sort of thing. The reason that we went with an in-browser editor versus letting people use Vim or VS Code or something is that it sort of came from our definition of what is Dark, and this idea that we have to have this 0-second interaction, 0-second deployment, didn't really make sense to put it directly into something else that was there, because this isn't traditional text editing in the sense that you're not editing bytes in a file on a disk on your computer. And we felt that what was necessary in order to do this was a structured editor, where whenever you made a change, it was safely deployed sort of structurally into production. So we didn't really get anything out of putting it in VS Code, apart from just that being somewhere that is comfortable. We might still make a plugin that sort of embeds Dark into VS Code if that's where people feel comfortable, but it would be very much taking the existing Dark and putting it inside it. So once we have this text editor, obviously it makes sense that everything else goes in there, right? We can see the connections to the other functions and, data stores and that sort of thing that you're using. We can see the traces in there. We can see the live values, which are the values that we derive from the traces to show you on whatever piece of code you're working on, and everything else as well, right? This is where we don't yet have, really good version control. There's sort of unlimited history, unlimited undo buffer that is sort of a primitive version of what our version control will be, but obviously that goes in the editor. Where you're doing search, where you're doing scaling, all of this, looking at cost and billing, like these are things that you kind of want them to be overlaid with the code. If you're looking at, for example, permissioning, right? If you want to allow someone to edit this particular thing, you want to see where you're editing it, the same thing, as opposed to going to somewhere in your cloud console where you can look at the IAM permissions and you're trying to derive from the IAM permissions how that relates to the code in your code base. Similar with billing. You go to the billing thing and you get a service, but you don't get this particular line of code is the one that's really slow. And that's the kind of thing that we want to build. We want to make sort of code the center of your application, because I really think it is. And then maybe this is, a little more on the visual side, but we think that the representation of code as either a GitHub list of repos or a list of, workloads in Kubernetes or a list of files in directories, we think that these are all terrible representations of an actual application. The way that most people think about their application, and you can think about this, when you join a job, how does someone explain to you what the application is? Well, they take you to a whiteboard and they start drawing boxes. They start drawing services and lines between them and data flows. And they say, the user's over here, the data store's over here, that sort of thing. And so we want that to be the fundamental representation of your application. It's not so much code lives in files and folders. It's, services are made up of handlers and data stores, and these ones talk to each other, and you can see the actual data flow, the actual live data flow of your program should be this is the way that you navigate around your thing. And it has all these overlays like permissions and billing and that sort of thing. So that's kind of the direction that we're going for this. I mentioned before, right? It's all about simplicity. It's all about removing all the things that you don't need. You don't need files and folders. You don't need Unix. You don't need deployment. You don't need a list of the lambdas that exist. What you actually need is, this is a representation of your application. Now you can drill down into the components of your application. Eventually, that's code. So that's kind of how we were thinking about, should this be Vim? It's well, no, because in Vim, you can't do all this stuff.
Yeah, that totally makes sense. I'm actually even curious why no one before came up with this idea, because it makes so much sense.
Right, doesn't it?
Just, you're building your tooling around actually the working code and the services, not around some abstractions that are totally made up just for things to work properly.
Right. I think one of the unfortunate things about Dark is, I talk to people about it, and after an hour, they're like, yes, oh my God, it makes so much sense. This is exactly how we should be writing coding. And if only I could condense that into 1 minute or 30 seconds, but I'm working on it.
Can you explain a bit how do teams collaborate around Dark projects? So it perfectly makes sense for an individual, but if you don't have Git, if you don't have explicit history with branches when everyone can see what everyone else is working around, how do you solve this problem?
So I think the simple answer is that today we don't solve it well in the implementation. It has been designed to be solved well, but we haven't got there yet. So today, if you are more than 2 or 3 users, you really wouldn't want more than one user editing code at one time. Largest number of people we have in a particular project is 6, and I hope they don't all edit it at once. I think it's a sort of a side project for that company. So where we need to go with it is exactly what you're saying. So we are going to do branches, or we already do branches, but it needs better interface, needs a bit more maturity, but we're doing them via feature flags. So feature flags are a built-in feature of the language. And we realized the reason the feature flags are so important is that so many things that people do are sort of approximated feature flags. So if you look at how people do code, 2 bits of code at once. Sometimes they do a branch in Git. Sometimes they'll even deploy that branch in like a separate environment, a separate staging environment. Sometimes they'll even put a separate container in their Kubernetes thing with, and use the load balancer to split between them. Sometimes they'll use feature flags, and sometimes they'll even use like architecture level feature flags instead of like code level feature flags, although they're different things. I don't like them being different things. Sometimes they do A/B testing. Sometimes they allow like users to opt in to features. And we realized that the vast majorities can be like simplified into a simple concept. We call them feature flags. We might rename them to branches, but it doesn't matter. It's the same thing. So that's going to be a fundamental part of how we do it. We want you to be able to, put code in production that isn't yet visible to users. And we want you to have a simple rollout mechanism. Firstly, I just use it for my own code, right? I just test it out, or maybe I log in as a test user and I say this branch here is only enabled for the test user. So you can already see that that's much more powerful than running it in a dev environment where you have to get like this production code down, or, you have to create a whole lot of test cases to like try to see it. Then you might enable it for your team. And today that might be the equivalent of like putting it in a staging environment. And again, it doesn't have to do that. You just change the permissions on the feature flag. The main feature for like, multi-user and teams and that sort of thing. But apart from that, it's going to look a lot like Google Docs or any of those like collaborative editors. Multiple people able to multi-edit this application, and things like, locks and permissioning to ensure that, people can have the control they need. And then lower level, there's merging and, very like fine-grained merging. Like if you're both typing in the exact same place at once, literally it's keystrokes being merged, and, feature flags, that sort of like middle level, and also the kind of large scale.
If even you are working alone, don't you need some kind of maybe snapshots in case you're walking around and you try to do some stuff? Sometimes you need a stable version of your feature. How it can be done with Dark?
We think that there's largely 2 states of programming. You're writing a new thing and then you're editing an existing thing. And so what feature flags let you do, basically you take an existing thing, you say I'm wrapping it in a feature flag, and then it gives you essentially another area to write code. And so that turns writing, editing existing code into writing new code. And then you can switch over to it when you're done. So I realized over the course of my career that editing existing things is really dangerous. And what you typically want to do is you want to build a new thing. And maybe you build the new thing by just like copying and pasting the old thing and editing it, but you keep the old thing running until the new thing is ready. Whether it's ready in production or whatever, ready with unit tests, saying that it's satisfactory, whatever that is, that's like the right way, the sort of the most safe, most productive way of doing things, because otherwise you end up deploying things that are broken, and then, they're broken in a way that you didn't expect, and then it takes the service down for everyone, and then the data's bad in the database, so you can't even do a rollback, that kind of thing. So you build the new thing, and again, maybe you just copy the old thing and then edit it. So that's sort of the format that we want people to take. Are they able to see the old thing? Absolutely. There's unlimited undo. We don't yet have visualization visualization is the wrong word. We don't yet have like an interface where you can access old versions of the code, but it is there. And we plan to expose that. So if you need to copy and paste code from like a week ago, but for existing code, it has to be safe to change this in production. And so that means keeping things the same. And a lot of the language and a lot of the infrastructure is dedicated to keeping things the same while you create new stuff. And that's why it's actually safe to do this deployment, this sort of like live deployment. We couldn't have this 0-second deployment without being able to ensure and building the language and the framework and the infrastructure around being able to ensure that things stay the same until you want to switch them atomically.
Since we've already started speaking about deployment, I think it's a good moment to switch a little bit and zoom out to infrastructural questions. And when we just started, Igor was telling his story about how he got interested with Dark, and this horrible story of him getting around AWS and all of that horrible stuff that nobody never wants to touch.
To be completely honest, I wasn't the only one who touched AWS on that week. Eugene helped me, but it was also no success.
Yeah, we've been doing it all together. So my question is that we've already discussed that Dark is an abstraction that completely hides the complexity of the infrastructure from the developer. Could you please elaborate more about how exactly does it work? How does it look under the hood for the project written in Darklang?
Yeah. The major components of Dark from an infrastructure perspective is the backend, sort of, the HTTP server, the queues, and the cron. And the queues are just implemented as, using Google PubSub, right? We are an abstraction over, an existing queue. The data stores are an abstraction over Postgres, and the HTTP servers, it is a ASP.NET HTTP server that is connected to the Dark interpreters. And then it's all deployed in a Kubernetes cluster in Google Cloud. It's very much built with like traditional components that fortunately our users never have to think about SQL. They never have to think about load balancers and API gateways and ingresses. And like, honestly, the amount of time I spent in Kubernetes is frustrating. In the same way that you felt frustrated by the API gateways, I get frustrated by ingresses and similar things.
Yeah. So I think I probably already know the answer because you said the keyword Kubernetes, but still I need to ask a question. If we'll try to zoom out even more and let's imagine the situation when there is like thousands of projects and thousands or tens of thousands of projects made with Dark, how this whole thing is going to scale up? Are you already prepared for that, or there might be some interesting things needed to be done to be ready?
Yeah, that's an interesting question. Couple of answers. One is that most people, when they're building something like this, right, they build containers and they have to deal with, I was just reading this set of tweets earlier from how Lambda is done and how they started with like, these like small machines, but then they moved to like Firecracker or something like that because they needed like, smaller containers. With Dark, if you're not using your application, there isn't a container running. There isn't like a resource that's being used somewhere. It sits in a database. Every request that comes in, we just fetch the program from the database. That's pretty quick. Or fetch it from a cache, really. And then we run it. So it's like, you don't have to think about any cold starts. There's no real cold starts. Like a slow application to run takes about 4 milliseconds to load from the database. So yeah, that's one aspect of it. Things that aren't being used don't really cost us anything except data in the database. And then the other side of it is like, how do we scale it is, and I'll sort of revert to my earlier answer, how would people do this today? We will need to shard, we'll need to take big users and do specific things for them. And we'll start to, we'll need to start to make automation that looks at traffic patterns and starts to pull things out into different, clusters, different runtime environments, that sort of thing. And what's intended for us is that the user never has to know about these things, and the user never has to make decisions that aren't important for them. Like perhaps they will make a decision like, I would like this to be hosted close to my users, and my users are in Indonesia. All right, so we're going to put this in the nearest thing, which is probably Singapore or something. That's the kind of decision we'd like users to make. In fact, that one we might even be able to make automatically sort of like move the data and that sort of thing. Fundamentally, the vision for Dark, and I'm not sure how close we're going to be able to hew to this vision because we are a much smaller team than we intended at the time, and it's kind of a smaller company than a big, massive one that I intended. But the initial idea was that Dark would be sort of a distributed system or an infrastructure compiler. You write the program and we will figure out where and how to best scale it and distribute it. I think that that's sort of going to be a much more longer term vision. And these days, really where we are now is we're trying to make this good for people with small uses. And small uses isn't as small as you think. Like we say on our website that we prefer to keep it to services that do less than, 10 requests a second. And 10 requests a second is actually, quite a lot. Like you can run most B2B apps, most SaaSes, most applications that people build are like, tens of requests a week. So tens of requests a second is actually like a reasonably provides sort of a medium scale, but we're we're not looking to get in the business for quite some time of doing the thousands of requests a second for customers and doing, really, really low latency stuff or really like high throughput stuff. I think that's just something that we're going to have to accept that users are going to have to do that somewhere else, which still leaves, quite really very large set of applications that are a good fit for Dark, even though we sort of lower the scope in that way. But we will get there. It might be 10 years from now that you can handle high throughput applications on Dark, but it's in the plan.
Cool.
Yeah. Looks like that Dark is more than just language. It's also tools and it's also the infrastructure itself. Dark seems like a complete vendor lock. What's your opinion on the problem?
Yeah, so let's start with why is vendor lock a problem? So users don't like vendor lock for two reasons. One is that the service might shut down, right? People are worried about startups that, just sort of go away. And the other is that they might put pricing up. And in fact, some startups in the past have done this. Like Google App Engine did a big pricing change that led to a lot of problems for their users, and a lot of people had to migrate off it. And App Engine was sufficiently far from the existing Java or Python that was quite a lot of work. So those are kind of why people are worried and why they might feel things are an existential risk for their business. So the major one for overcoming vendor lock, or for overcoming this fear of vendor lock, is to build things on Dark that are sort of low risk. So one of the things that we tell people to do if they're worried about it is just build the prototype on Dark and then, switch it to Node or Go or, whatever is your thing. You will save enough time just building the prototype on Dark that it will be worthwhile even if you go to rewrite it, because at least when you go to rewrite it, you'll know what the application is. You'll have made all sorts of design decisions and things, and you'll have iterated quickly on the front end. It's okay, it took us a week to build this prototype. Now we know what it is. We've saved a month of what we would have written in Go or Node or something like that. And then the other is, don't build your main applications in Dark if you feel that that's a risk for you. We will also say that we don't plan on putting the price up. We don't plan on shutting the service down. But I'm thinking about people who are conscious of this risk. Use it for your internal applications. Use it for receiving messages or sending messages into your Slack when certain changes are made on GitHub. Maybe even use it as a prototype of just a service. Your main application is a monolith or a microservice. Use Dark for just one service, sitting off to the side, or 2 services or 3 services. Eventually, 20 services, great. We sort of recognize that this vendor lock-in is a side effect of all the things that we do want. We don't want there to be vendor lock-in. It would be great if there wasn't. And one day we might build a tool that will compile your Dark applications into a Node or a Go application or a Python application or whatever, so that you can, get away from the vendor lock-in. Obviously, your data is your data. You can pull your data out anytime. That's very easy to do. So it's really sort of a case of risk. Are you worried about us increasing the price? And 2 ways to solve that. One is some sort of demonstration that we have not increased the price. Obviously, Dark is still free. And the other is, for the other concern, will Dark shut down? Over time, that concern becomes less because Dark has not yet shut down. We've existed for 6 years. We've been live for about 3. And Dark has not, shut down in that time. But, once we have revenue and we have thousands of customers using us and a much bigger team and all that sort of thing, I think people will be much less concerned about those. You can look at Firebase as a good example. Okay, technically you could move off Firebase, and a lot of your Firebase app is written in JavaScript or is written on the client, so sort of less of a risk. But there are hundreds of thousands of people who build their applications on Firebase, or these other proprietary things. A lot of cloud stuff is proprietary as well. We're not happy about the lock-in, but we recognize that it is impossible to do the things that we are trying to do without it, or without having it as a side effect. So, sort of our goal is on mitigating it and demonstrating that the risks that people face, we don't do that. And I hope we'll build trust in that over time.
There is a great article by Joel Spolsky called The Law of Leaky Abstractions.
Mm-hmm.
It says that any non-trivial software abstraction at some point of time will eventually leak, will eventually expose the underlying details to its user. So Dark is definitely a non-trivial software abstraction.
Mm-hmm.
And In my opinion, it could leak in so many ways. For example, you don't work with the database, you can't optimize its indexes, so some maybe trivial data query may be too slow and you don't have any tools to fix it. So that complexity that you want to solve, sometimes it's not a bad thing. So my question is, what is Dark strategy with these kind of issues? What does Dark propose you to do when you need to dive into details, when you need to expose these underlying details?
Yes, what we want you to do is contact us and we will fix it. I know, it's an odd answer. Yeah, fundamentally, like when you're a platform, you often can't provide people with access to the internals. Now, Dark is source available, so you can look at the source code, you can sort of like figure out why it's happening, you can even contribute fixes. And part of the reason that we went source available is because sometimes people get stuck because of the abstraction, and we wanted to at least let people be able to dive in and fix their own thing, even if we weren't able to prioritize it. Part of what I was saying about that infrastructure compiler earlier, part of our goal of that sort of, magical infrastructure thing is that we will, automatically add indexes and automatically figure out things that are low performance. And to a certain extent, part of the removing complexity of what Dark does is drawing a box around a lot of functions, right? You don't need DevOps engineers. That means we need to be your DevOps engineers. You don't need security, or you don't need as much security. There's a lot of still front-end security stuff that you need to know, or API-based security that you need to know. But, for things like libraries and, running things in the cloud, we take on that role ourselves. And so, the counter side of you don't have to do it is you don't get to do it. And vice versa, right? You don't get to optimize your own indexes because you don't have to optimize your own indexes. So it's similar to the last point of, that is part of the trade-off of a platform. And we hope that the trade-off is worthwhile, and we hope that we will be able to, solve that issue for users. And what if we can't? Like, what is the escape hatch? As always, it's the HTTP server. So like if there's a particular thing that you can't index, you can spin up a HTTP server that just is a microservice around that particular thing that you're doing. Or perhaps we will have drivers, or well, maybe not drivers, but like SDKs for some other things, like I was mentioning with Elasticsearch earlier. Maybe there's an equivalent thing for whatever you're stuck on, and you can keep 90% of your app in Dark, and you can keep the benefits of this one thing. Okay, you have to go and suffer the old way of doing it for that thing, and hopefully that won't take too much of your time, and all the other engineers who don't touch that will have a custom abstraction over it.
So as far as I understand, this idea also lies inside the business model. So the larger your application will be, the more complex it will be, the more support it will require from your side, and this support will be another cost for a client. Do you plan to provide paid support for people who will need it for their projects, or it's just on case-by-case basis?
I think we plan to provide paid support. So just in terms of like, how will we pay for Dark? How will we make Dark sustainable? We plan to charge for the service. We plan to charge for infrastructure. We plan to charge for things that cost money, you pay for. So similar, you can pay Google $250 a month to have a support contract where someone replies to you more quickly. Sure, I think that's a good thing. You can work with certain vendors to implement custom stuff or to like move things up the roadmap. Sure. Yeah, that's a way that we will happily work with you. So yeah, I think that we will provide those things because people need those things, and also we like money. So
okay, I think you might notice that we are asking kind of a tricky question. So I have more or less another tricky one.
Oh yeah, I've been asked all the tricky questions. Go for it.
Okay. Actually, I just wanted to know your thoughts about the scope of the project, because during this whole discussion, there is one like red line that the project is about the whole stack of development. So it involves programming language, it has all the infrastructure, it has the problem of code versioning, etc., and so on. Definitely sounds like an interesting task from the engineering perspective, but from my point of view, it looks like it's a really vast scope. Is it really manageable? I mean, do you plan to probably reduce some parts of the scope, or maybe you have some tips and tricks or some kind of MVP, which scope functionality needs to be done first on each layer and then just try to make it better and better step by step? So what's your thought on that?
Yeah, so you're definitely right that the scope is tricky. I initially thought when we started building Dark that the scope was so large that it could only be done with a lot of money and a big team. And obviously we're a much smaller team now. And as deciding, to continue with the project as a small team, part of that was deciding like, is it feasible? Can we do this with a small team? I think we can actually. And I think that part of that is sort of like looking at this a little more as a community project, exposing things like the package manager, like the source code, making it so that people can do things without specifically having to rely on us to get there. That's kind of one aspect of it. Another aspect of it is trying to do as much in Dark as possible. So that has been a recent shift for us, but we've started rewriting, whenever we write new features, we try to write them in Dark first. We are also trying to rewrite the existing features, the existing editor features in Dark where possible. At the moment, I'm doing a re-implementation of our traces, like an internal thing. And part of that is built into the core, but part of it, especially around cleaning up traces and being able to query them and that sort of thing, is something that we're going to build in Dark. So I think that being able to leverage that it's faster to build stuff in Dark is an important way that we achieve scale. And certainly as we build sort of the non-essential parts of it, like things like, user signups and marketing and, chat functionality, collaboration functionality, this is all stuff that can be and will be built in Dark, because it gives us not just the ability to be able to use our stuff and test it out, but also the ability to just move faster and be able to do more.
Mm-hmm. Okay, got it. And if you don't mind me asking, just curious, how much time do you personally spend on Dark? On developing Dark, and if it's possible to know how this time is split across development, across maybe some marketing tasks and something else, would be great to know that. Just curious.
Yeah, so I'm on a podcast now, so that's marketing. In an average week, I'm probably coding about 40 hours, and I'm probably doing about 10 hours of other stuff personally. And then we have part-time help with running the company. That's 10 to 20 hours a week. And then there's another engineer, Stashu, and he's whatever a regular engineer does, 40, 50 hours a week, that sort of thing.
Mm-hmm. Okay, thanks.
Now to my question. Can you please compare the current vision of Dark and the one that you presented when you unveiled the project for the first time? How much did it change? Did you maybe reduce the scope or increase the scope?
I think the scope is largely the same. It's still largely building backends. A couple of years ago, we looked at our financial situation. We realized that we weren't able to keep going at the pace that we were going, and we had 10 people on the team. At that time, I looked at okay, are we doing the right thing? Can we build what we're building? And looked at reducing scope to be, perhaps this is more of a programmatic Zapier, or perhaps this is something like a Google Forms programmatic backends. And I realized that none of those were compelling. Those are things you could build in Dark. It might be nice to have a library that does some of those things, but it's not really a compelling vision in the way that the original Dark vision was. And continues to be. I think that this is the full vision is still incredibly compelling. So a lot of it is more, what are we doing now versus what are we doing later? I talked about stuff like the infrastructure compiler. That's going to come later. And so I don't imagine people spending millions of dollars a year in Dark compute, because that just doesn't make sense with the sort of infrastructure that we have now. So it's much more now for smaller projects and for lower scale projects. So that part of the scope gets cut out, or at least gets put until later. Things that we had already cut out that we thought we might get to at some point, we thought we might make a front-end framework that works nicely with it. That's not going to happen. We thought we might make a thing that generates iOS apps. It's probably not going to happen. But also those are things that are done more nicely by other stuff in the ecosystem, and perhaps we'll partner with someone. So perhaps we'll partner. There's a tool called Glide Apps, right? That is a super nice way of building applications. And there's a bunch of them, right? We don't necessarily want to be want to prefer one versus the other, but it might be nice. The source code is open. We are very happy with people who want to build integrations with us and build like lovely things. And we imagine that a bunch of that will come from the community. People who are building on React or Vue, I think are really good examples. Like, should we have a library that makes things really easy to build React apps with Dark? Absolutely. Some of that will be built in Dark, some of that will be built in JavaScript and React. So a lot of the scope is just sort of like moved to community and moved to like the people who are building on top of Dark. And right now there's not a whole lot of those, but I think as we make the language a lot better and it starts to grow, we'll start to see a lot more sort of that scope that we would initially have taken on ourselves be things that the community is excited to build.
Okay. And what are the next biggest plans for Dark right now when the big compiler rewrite is over? So what are the most important things that you plan to ship in 2 years?
The rewrite is done. We finished the rewrite.
Yeah. But what next?
The next thing that we want to work on, the thing that is guiding us at the moment, is making Dark really good for solo people. So we've put off the scope a little bit of like multi-user sort of thing. We want to make Dark really good for one person who's building a simple backend. I don't think we're there yet. I think there's obvious features like completing the language is kind of the major thing. Removing a bunch of the jankiness, making Dark easier to learn is sort of what we need around that. And then the next step from that is, how do we make Dark excellent for those users and good, but not yet excellent, for teams of 2 to 3 people who are, again, still building small projects. And then after that, it'll be 2 to 3 people building more medium-sized projects. And that's how we look at sort of the roadmap and the feature set at the moment. Just who is our user at the moment that we want to make this good for? And you can sort of draw out from that. Package manager is going to be an essential part of making this like a really good thing for single users. That user authentication is going to be an important part of it because that's one of the first things you do when you build any sort of application. Yeah.
And how many projects currently use Dark, and what types projects are they?
They all fit in, this relatively simple niche of we are receiving data from somewhere and we're talking to a handful of APIs. Almost all of them are talking to 0 or at least 2 or less APIs, because Dark doesn't really provide very many SDKs. There's about 20 that we provide some limited access to. You can send a payment on Stripe or a tweet or a message on Slack, but really not much more than that. So users have to build that themselves, and that really limits the scope of what people are willing to build in Dark when you can just go to Node and you have a fully fleshed out SDK. So everyone who's sort of building and who's stuck with it is, for the most part, they've a bunch of data that they need to store. Maybe a canonical example is this user who connects a bunch of thermostats around his house to it, and he's just, every hour is just measuring what the temperature is and sends an alert if it gets too hot or too cold in some part of the house. That's kind of the things that people build with Dark. That sort of application, you could imagine. Like, there's so many applications that are just like, oh, I'm just going to take a little bit of data from here, and then I'm going to send it over there and store it and do some minor aggregation. That's really what Dark's good for.
You mentioned that you try to pass as many work to the community as possible. And what about the current ecosystem? How many, SDKs for third-party services are already there? For example, if I want to make a chatbot for Slack or for Telegram, Facebook, something else, will they be SDKs or I'll have to do it on my own?
So right now you'll have to do it on your own. We have the start of a package manager, but right now only employees can add functions to it. And realistically, we haven't added any functions to it in quite some time. And the reason for that is that we're trying to complete the language because we don't want all these SDK things to be built wrong. So we don't have like good records. We don't have some types like enums, the sort of things that we discussed. There's only like a handful of those sort of built in and sort of janky to use. So people are basically using polymorphic dictionaries with like different types in them, essentially dynamic objects. And we don't want this big ecosystem to be built around what we feel is the wrong the wrong abstraction. So we're trying to build that first. And so right now users can't add them and you have to build it yourself. And there's no good way of sharing. Like you can share between your multiple canvases by just copying and pasting between them, but users can't share in a way that, that they would be able to on GitHub or something like that. And that's by intent because we don't feel that we're there yet. That's what we're looking at as part of the current push.
Okay, I think we're moving to the end of our conversation. And just before we finish this really interesting discussion, I have one more question. Maybe it'll be a little bit personal, but still, well, can you share what kind of your own personal insights from creating and evolving this project did you have? Maybe there is some interesting ideas that you consider to be specifically successful, or maybe there are some things that you would change in a different way if you had a chance to do that. So could you please tell us about that?
Yeah. So I think the main insight that I sort of fall back on every day is just how valuable immutability is. And I mean that both as a language feature, but also in terms of what I said about building new features and then swapping them in fully while leaving the old features there. When I think about earlier in my career and all the things that went wrong, I think that one thing, we will build the new thing and we will deploy it alongside the old thing and then we will switch to it, feels like a silver bullet almost. I no longer really add things to database tables. I build a new table and then I switch it over. I no longer, change modules all that much. There's a new one and then we'll develop the full thing. We'll deploy them alongside to a small set of users. We'll figure out all the things that are going wrong and then we'll finally, switch it over. I know everyone does this anyway, but does it in smaller amounts. I found the more and more I use it and the more places that I use it, the more valuable it is.
Mm-hmm. Okay.
The other thing I'll say is Dark's trace-driven development. Whenever I go to anything else, it's just night and day. It's better than debugger. It's better than logging. It's better than observability. It's just this fundamentally amazing technique to have these values in your editor automatically stored. And I just wish that every other ecosystem could. I know that in order to be able to implement this, you need data from 3 different places and you need to put them in VS Code or your editor or whatever. And I know that that's fundamentally hard. And it's only easy because we do all of it in Dark, but I would like to see that in many, many more places.
Great. Personally, I wish you success with your project because I really hope that one day you will expand it to mobile development as well. And as a former mobile developer, I would be happy if I would never have this question, which technology to use, native, Kotlin and Swift development or React Native. I would be happy to build the whole system, both client and server, with Dark because it sounds amazing.
Brother, you have Kotlin multi-platform. You can use Kotlin for all platforms.
Thanks, nope.
Yeah, I mean, I hope that someday there'll be something where people are invested enough in Dark that they're just I'm going to make Dark build mobile things now. I'd be super excited about that. I think one of the things is I personally avoid building things I don't understand. I understand backend. I don't understand iOS or mobile or Android development. And so I'd be excited for people who did understand that to sort of, even to just tell us what that needs to look like in Dark, what would be exciting for Dark to add for mobile development. That's kind of where we want to lean on the community, not just to build it, but also just tell us what does this need to be.
Okay. So Paul, thanks for joining us today, sharing your vision on the backend development.
Thank you so much for having me. This has been fun.
Thanks. I hope that if some of our listeners next time when they will have some not very big task that can be done in a standalone microservice, they will consider doing it with Dark, because at the very least it has lots of beautiful ideas built inside, and they will definitely make you a better programmer. So I think you should definitely give it a try.
Absolutely. It's a little rough, but it's good.
Okay, we wish you luck. And thanks for everyone who was listening to us. We'll be very, very thankful if you will leave some feedback. We'll add some links both to Darklang and to our own social networks and community to the description of the episode. So please leave us feedback, talk to us. We'll be very, very happy. Thanks everyone for listening.
Thank you.
Thanks, guys.
Yeah, thank you.
And bye.
Bye-bye.